Hello and welcome back to my channel. This is part 2 of my PlayStation 3 Repairathon series. If you haven't watched part 1, I would definitely recommend you go and watch it. I'm gonna link the video down below in the description. Now, before we crack on with PlayStation number 2, I'd like to share something with you. Within the PlayStation 3 community, there's always been a wealthy amount of opinions on why these GPUs tend to fail. Whether the capacitors are to blame, the BGA solder balls are to be blamed, reflowing can fix, reballing can fix, wrapping into a towel and overheat the PlayStation 3 to death can help. It's always been unclear what was causing these major issues, which more or less affected all the PlayStation fans back in the days. It wasn't just the PlayStation 3, it was the PlayStation 3, the Xbox 360, many if not all the AMD and Nvidia GPUs back in the days. Now, I don't want to spoil what happened in episode number 1 in case you want to go and watch it, but in between that episode and this one, a very known member of the PlayStation 3 community released a video, which I believe is his first video. His name is Felix. I'm going to link the video down below. It's kind of on the long side, but if you are interested in what's happening here, I really recommend you go and watch it because it's absolutely amazing. The way it's made, the amount of information it's sharing is absolutely gorgeous. It's impressive. It's an impressive piece of work. The conclusion on this video on these large BGA GPU chips seems to be pointing not at the substrate where the BGA balls are actually attaching the chip to the PCB, but to the little solder balls which are basically attaching the die of the GPU itself to the substrate, which is basically this little piece of PCB which then gets attached to the board itself. In a nutshell, what seems to be happening back in the days is that there was a design flaw in how the chip was actually put together mechanically, and that the normal thermal cycles of the PlayStation, of the Xbox or whatever, was eventually causing physical damage inside the GPU chip. So it turns out that there is no fix for this, that all we're doing when we fix PlayStation, that obviously we're talking about the GPU problem, is only to warm up the chip, and the chip, for a number of reasons, because of thermal stress, it will fix itself for a limited amount of time and eventually will fail again, because again, there's no solution to the design flaw of the chip itself. So the reason I'm saying this is, number one, I really don't want to spread any more disinformation on the subject. Number two, again, let's take both my previous video and I would say this video as well as, we're having fun with the PlayStation. I'm not here to say the tokens are to blame. I'm not here to say who's right or who's wrong. I'm just playing with the PlayStation, see what if I can make them work again. But please bear in mind that it looks like the main reason for the GPU failure of PlayStation 3 is inside the chip itself, and that cannot be fixed. It can be fixed if you swap the original chips, which are the 90 nanometers chips, with the 45 nanometer chips. They are physically compatible, and there is a way to do it. I might be doing it at some point if I ever have time or the guts of doing it, to be honest. But if you end up with a PlayStation 3 FAT with a 90 nanometer chip, which is what was normally installed in those PlayStations, the chip will fail at some point. And if it has failed already, you can revive it, but it will fail again just because of the design flow of the chip itself. That's it. With that being said, with that in mind, let's move on to PlayStation number 2 and let's see what we can do for it. Okay, let's move to the next PlayStation. According to my note here, this is a classic yellow light of death. So I've got power, let's turn it on and see what happens. I can hear the fan spinning, so it looks like 12 volts is coming. It's just it's dying immediately. It's a bit weird. Anyways, I'm not too familiar with this. Now, one peculiarity of this unit is this. This is a factory sealed PlayStation 3. It's amazing because you don't find many of them, to be honest, nowadays. It's completely sealed, which is always a good thing because it means that there's nothing nasty has happened inside. Even though, I need to show you something. Now, I'm sure that many of you, if not all of you, are familiar with the towel trick or the hairdryer trick. So when you have a yellow light of death, some YouTube videos or, some instructions online, they say, hey, wrap your PlayStation into a towel and let it overheat and that will fix it. Or use a hairdryer and push hot air at the back of the unit and that will fix it. Now, do you see anything suspicious here? I'll leave you like a couple of seconds. You might see this part here, which looks a bit deformed, but I need to show you something even worse. I don't know how much this is visible. The plastic inside is completely deformed, it's completely melted, but the unit is sealed. So either this PlayStation overheated to death, which I don't think so. I think the PlayStation would protect itself at some point. Or someone has applied hot air gun, like not the hot air station for reworking, like the one they use to remove paint from materials. But surprisingly, the outside plastic has survived, even though, again, this part here is deformed. To be honest, I think it's only a cosmetic thing. I don't think I will find anything nasty inside, but yeah, well, let's take a look and see what's inside. Okay, so that's definitely much cleaner than the other one, and I think, well, the power supplies could be the same or / compatible to the one I have, so maybe we can test that straight away. Right, so here's the course of action for this unit. First thing I'd like to try, if the power supply is compatible, is to try the other power supply. Because again, yes, I could connect to Syscon, but if it's just a power supply, it's an easy one, and I don't mind an easy one every now and then. If it's not the power supply, then I will have to connect to Syscon and see what the error message is. Right, I'm a bit puzzled as these two power supplies look like physically identical. They have the same connections here. And if I look online, well, the one I have, the spare I have is for an older model. So being an older model, the power supply is more powerful because obviously the newer the PlayStation, the more efficient they are. It's more powerful on 5 volts, on 12 volts. You have the same pin out on the 5 volts. There's the same pin out on 12 volts. I can see it works like physically, but the PlayStation wiki basically says that these two are not compatible. I don't see why, but yeah, I mean, if someone on that wiki said that this power supply is not compatible with this PlayStation, I would say let's not push my luck. I would say let's connect to Syscon and see what the problem is, because I don't have, again, I have 3 PlayStation with 3 different power supplies. Let's connect to Syscon, I guess. Right. What happened here? It's melted. I mean, I can't believe the PlayStation would run so hot that this happens. But the outer plastic is fine. So I'm not entirely sure. I mean, it's fine up to some point because it's deformed here. I don't know, to be honest. Okay, so the board is out. I don't really see anything, obviously wrong on this board. I can definitely see the thermal paste is more or less very dry. So the next step is to identify the Syscon pins and solder some cables onto them. So here is where the motherboard name is, SEM001. This is the area. And so according to the schematics, I think the pins I'm looking for are this one, 1, 2, and 3. So let's go ahead and solder some wires to these pads, plus ground obviously, and we'll move from there. Okay, I've got the PlayStation put together. It's not in its case, but that's fine. I'm not planning to power it up. And I actually have the power applied, so the PlayStation is currently switched on as in standby. Here you can see I've got my serial adapter connected to the RX, TX and ground connector. It's plugged into the USB port of my computer. So let's move to the computer and let's try and access Syscon and see what he says about this PlayStation. Okay, so I'm here on my laptop. The command is the same as usual, as the same port, and the same chip is the million, whatever it's called, chip. So let's try and connect and see what happens. So let's send the authorization request. And it works. Perfect. So let's look for the error codes. Outlog get 00. Okay, so we have an A0403034. Let's check the next one. It's a slightly different one. It's A0404322. So let's see what happens next. And we have, again, the same error. Skip going. 3034 is what we got before. Number 5, 4322. So it looks like it's a sequence of 3034 and 4322. Perfect. Okay, so let's check on the web and see what we get for 3034. Now we know that A0 it happens immediately, so that's normal. And then we have a 40. Well, I'm not sure what the 40 stands for, but we have 3 error message and 3 is a booting error. So I'm looking for booting error. So error code is 3034. So if I scroll down where the booting errors are, 3034, cell RSX communication error. Now I had a look at this section and as usual, it could be a number of things, but it seems to be pointing to basically communication error between either the cell, which is the CPU, or the RSX, which is the GPU chips. It could be anything. It could be the chip has failed internally. This is what sometimes can be resolved with a reflow/reball. Obviously, there's no guarantee that that's going to happen. And what was the other error message? We have a 4322. And indeed, there's a mention here that says there is often a data error for something that also appears, but not always. 4322 seems to be an RSX error message. What the website says is the most common cause of is a BGA defect on the RSX. Not what I was hoping, to be honest. I was hoping for something a bit more practical, like again replacing a capacitor or something, because again reballing, reflowing is always shooting in the dark, to be honest. But I guess the next step is going to be to reflow the RSX and see what happens. Now, one very big issue when reflowing/reballing a BGA, a large BGA chip, is popcorning. Well, that's supposed to be part 2 of my BGA test video, but I can anticipate you this, that what happens is you have moisture into the chips, and when you run the chip at a very high temperature, as you have to when you're reballing or reflowing a chip, the moisture could escape in a destructive way, basically destroying the chip itself. Now, while I was looking for some solutions for this, because it's not really something that it's easy to resolve, I actually come up with this little box. I call it a dry box. Let me show you what's inside. So first of all, I have a hygrometer inside this box, and you can see it's reading 15%. Usually it reads in between 10 and 15%. Inside this box, at the bottom, I have these little silica balls here. It's basically a material, apparently it's inert, it's totally safe. And it absorbs humidity. When it's full of, well, basically saturated with water, it becomes green. Now, I've been using these for several months now, and they've been in this box. I never regenerated them, which is basically done by baking them in an oven. The idea is that I keep boards which I want to reflow or reball into this box for, say, a week, and then I bake them as well a little bit, and that hopefully, I can't be certain, will reduce the moisture inside the chip and then the boards and everything to a point where popcorning does not happen. So what I'm going to do now, and let me close this before I put unnecessarily moisture inside the box. What I'm going to do now, I'm going to remove the motherboard from the PlayStation, and I will be leaving in this box for a few days time, and then I will bake the board just for extra peace of mind. Only at that point I will be happy to reflow the SRX, and we'll see what happens. Now, one other thing I have to do before I put to sleep put to sleep sounds bad, before I store the motherboard inside my dry box, I will have to delete the RXX. The reason is I don't really want to reflow any chip with a heatsink on top. I feel it's counterproductive. So let's go ahead and delete the RSX. Doesn't look like. So again, the next step is I'll give this a clean maybe, and then I'll just store it in my dry box and leave it there for a few days, and then we'll meet again when it's time to do a reflow. And while the board is getting ready to be reflowed, I've been thinking whether maybe I can try and give this plastic shroud some sort of original shape. I guess it's going to be probably easier to damage it further than anything else, but I guess I can try it. Only I would say this part is severely damaged. I definitely would like to address this part here, which is severely deformed. So I would say let's take out the shroud and see how it looks, and then I think I'm not going to use my hot air station, I'm going to use my heat gun and see what happens. Right, that's the best I could do. To be honest, it gets pretty flexible when it's warmed up, so if I need to change it a bit, I can still do it. My concern is probably some of these parts are not going to fit in the case anymore. Yeah, it's not the best. I know. Is it better than it was before? Maybe. But again, the fan spins, and hopefully all the screws will fit as well. Since I'm here, I thought it was a good idea to delete the CPU as well, to save time later. Now I've successfully done it on 2 PlayStations, it does not feel such a huge task. I need to be careful, but the first failed attempt definitely helped me learning what to do, and most importantly, what not to do. Thermal paste under the HS was pretty dry, so I guess it had to be done anyways. This is basically my shop oven. I didn't want to buy an oven. I know they're very inexpensive, but you need some space to store them, and I don't do this very often. So I I made this little cover, which is made with some insulating material, and I just run the preheating station at 120 degrees for a few hours. That will more or less keep the board around 90, 100 degrees. It is a bit energy inefficient, even though it's actually surprisingly not too bad. The preheating station is mostly idle most of the time. So the board has been baking for a few hours. It's now time to uncover this and get ready for the reflow. Okay, I'm ready to begin. I have set this up with my hot air station nozzle holder. This is the biggest nozzle I've got, which I think I purchased for the PlayStation 4. It's a bit tight for that chip, but that's the biggest one I have. It should be okay, but it's just. And I've never used that one, which is pretty big. I guess this is where my powerful 200 litre per minute hot air station comes into play. I will have to guess a good working temperature. Now, this is lead-free solders. It melts at 220 degrees, which means I need to reach, well, at least 230 degrees on the chip. So we'll warm up the board up to 180 and use something around 320-30 degrees on this hot air station. It's a big nozzle, so I'm assuming the temperature will drop a bit by the time it actually reaches the board, even though I will use a pretty high airflow. I'm thinking something 120, 140 litre per minute. And I also have a thermocouple there. They're not very reliable in terms of temperature reported, but I don't know, it will give me an idea. And if you can see that, I put a little strip of aluminium tape under it. It was one of my viewers' idea, which I tested at some point. It does make the reading a bit closer to what it is, but it's still not as accurate as a laser meter. Now the laser meter is there. The problem with when you're using these big nozzles is the chip is under the nozzle. So I can test the temperature around the nozzle. That will give me an idea, but unfortunately there's no way to test the temperature inside, where the chip is. That's a bit of a shame. I also have a light here, which hopefully will help me see what's going on. So let's turn on all the extractions, the big ones, because there's going to be very smoky, and let's give it a go. The reflow did not really work as I wanted. I think I made a few mistakes here. First, I did not really consider that this is lead-free BGA. All my BGA experiments were mostly done on leaded solder, which melts at 180 degrees Celsius. Lead-free solder melts at 220 degrees Celsius. It's a 40 degrees delta, which I should have considered a bit better. I know I can reflow leaded solder using 320 degrees on the hot test station. I did not capture the hot test station display here, but I think I only went up to 340 degrees Celsius on this occasion, and that might not be enough to reflow lead-free solder. Second, I did not consider I'm using a massive nozzle here. There must be some heat escape through that large metal body, which must be taken into consideration. So I suspect that the temperature should be risen even more to compensate for the larger nozzle here. Finally, the thermocouple is more or less useless. It senses the air temperature, not the bore temperature. I really don't understand what kind of information it can give to the user, to be honest. Oh, and I always get very nervous when attempting these things. My hands start shaking like crazy and it becomes difficult to nudge the chip. It would fly over the room if I touched it. Definitely, I couldn't be a heart surgeon. And despite my precautions, I heard this sound during the process. That might indicate popcorning of either the chip or the PCB. That was really disappointing after all the preparation, but I might have dragged the process for too long, as I think the temperatures were way too low. Now, bear with me and I'll try to test what I just said in a minute. Hey, this is me from the future. I'm editing the video, and something I really wanted to experiment with a bit real quick is whether I made a mistake in choosing the temperature and the airflow, because obviously all the tests I've done before this video were done by using this nozzle here on the left hand side, which is 12 millimeters. It's pretty large, but it's not as big as this one, which is 45 by 45. My theory is that if you look at my hot test station, and to be honest, I believe they're all the same, the temperature sensor is actually inside the handle. That is where the temperature is sensed. But long story short, what I'd like to do today is to measure what kind of temperature I'm reading when I'm using this more normal nozzle, 12 millimeters diameter, and what kind of temperature I'm reading using the same temperature, but to be fair, a higher airflow, when I'm using the 44 by 44 millimeter nozzle. My test bench is going to be a multimeter with a temperature capability, and I have the thermocouple, which is attached to this aluminium plate. Is not touching the aluminium plate. As you can see, the actual thermocouple is like, I don't know, less than a centimeter from the surface. The idea is the aluminium is there just because I don't want to burn my table, but I don't care about the temperature of the aluminium. I want to sense the temperature of the air. I want to know what kind of temperature the chip is getting. So my hot test station is set to 320 degrees, 90 liters per minute. It says it's reached temperature. I'm gonna keep my nozzle, I don't know, less than a centimeter. And I'm getting now to 320. Okay, let's now try and do the same test. So I'm gonna plug the bigger nozzle, gonna turn up the airflow to 120, same temperature 320 degrees, and I'll try and keep the hood here, the thing, it's kind of a bit closer to the aluminium plate, because obviously it kind of acts like as a hood. And let's see what kind of temperature we are getting. And as I suspected, we are nowhere near the temperature that I was getting before. And again, it's a matter of, I would say, airflow. It's a matter of the fact that it's a big nozzle, so obviously, some heat is being dissipated by the nozzle itself. It's got a big surface. So we are maximum 250, and that is why I couldn't reflow that chip, or I could barely reflow it. So to get to the same 320 degrees temperature, first of all, I'd like to try a higher airflow. So let's try the maximum airflow. It's very interesting, there's not much difference. It's only like 10 degrees difference. So I would say probably we can go down to the same 140 liters per minute, and I need to crank this up to get to the same temperature. It's about 100 degrees, so I'll go to 420. Let's give it a few seconds for the machine to reach temperature, and let's try again. Yeah, more or less we got to the same temperature. Maybe we can do 410. That's exactly what I was looking for. We know what happened. It wasn't a matter of airflow, it was just a matter of temperature. I guess this is lesson learned for the future, and that's it. That's it from the future, and back to me in the past. I don't know. I doubt this is gonna work. Let it cool down, and we'll try and power up and see what happens. Right, I've got the PlayStation partially reassembled. It should work without the DVD, ROM and everything. Got the fan connected, obviously, but I don't see the point in reassembling everything if it doesn't work. And I would say, let's give it a go. 3, 2, 1, go. Boo. Meh. Well, kind of expected, right? No, still yellow light of death. I guess I can try and log into Syscon again to see whether the error message is still the same. I suspect so. I doubt I can fix this one, to be honest, but well, let's see what happens. Okay, well, something happened. I can't explain it. Currently, the board is actually plugged into 5 volts. Because basically, every time I give power to the power supply, so just plug the power supply, this happens. So I'm giving it power now. And that happens. Now, I don't have a fan or anything, but I can tell you that it doesn't do anything. There's no activity. It turns green, it beeps. There's no fans when it's fully assembled. Nothing turns on. The buttons here don't work. I don't know what happened. I thought it was maybe my mangled Syscon wires. So I just resoldered them several times, then eventually just removed them completely just to see what was going on. And it's still doing that. And I tried again connecting to Syscon in this state because I thought, well, maybe the Syscon chip is actually up and running and I can see what's going on. But no, nothing answers. I have the green light. Again, this is not the green light of death, aka YLOD, I guess, because that is when the PlayStation powers on, the fans goes on, everything, but nothing happens. But no, again, if I fully assemble it, it's still like that. There's no 12 volt. The power supply doesn't actually engage with 12 volts. There's no error message. There's no nothing. And again, I don't have to push the button to turn it on. But if it was an issue with the button, it would actually turn on, but it's not. And honestly, I'm a bit at a loss here because again, I can't access Syscon. I can see some voltages on the board. I can see there's 3.3 volts here, which I guess is the Syscon voltage, but the Syscon doesn't respond. And it's weird because it was working. It was still yellow light of death, but it was working. I'm not sure exactly what happened, but unfortunately, I have a bad feeling about this board. Not that I had a good feeling before, because again, the error message was one of those weird one which you don't really know. I've also checked the board with the thermal camera. Basically no activity. I can see a little bit of glow on the Syscon chip, which means it's doing something, but there's nothing shorted or anything. So I don't know, to be honest. And unfortunately, I couldn't really do anything to revive this PlayStation. I've asked the community, nobody has ever seen anything like that, and I got totally stuck. I don't really know what to do. As mentioned, I probably made a mistake with the reflowing process, but I still don't understand what happened, because it was working as soon as I put it back together. Well, working as it with the yellow light of death, but at least it was doing what you would expect the PlayStation to do when you power it up. And then it started doing that weird thing, and honestly I had no idea what's happening. But especially after what Reap Felix mentioned about the PlayStation 3 GPUs, you know, I've decided it was not really worth investing any more time in this PlayStation, which unfortunately I can't repair. We do have another PlayStation to fix. That's going to be the next episode, and that's going to be a quite important PlayStation. That's a backward compatible PlayStation, so I really would like not to break that one. What happens, we will know in the next episode, which is going to be out soon. I hope you enjoyed this video, even though I couldn't fix the PlayStation this time, but I hope you have fun watching me tinkering with this PlayStation. If you enjoyed the video, I would really appreciate if you could hit the like button down below, and also consider subscribing to this channel if you like what I'm doing. For now, thanks for watching, I hope you have a great day, and I hope to see you again soon here on my channel for my next videos. Thank you very much, enjoy your day, bye!